Hi there, Jason Ross here again. This is going to go on my Modern Democracy channel, I think, but I'm going to be doing a couple of videos probably in sequence here. The other one will probably end up on my retro channel. So I've been pretty heads down into learning how to use Claude code, Claude's projects to do coding, and just how to use projects to kind of do a number of fairly complicated tasks. So I thought this might be a good video to just kind of go over my methodology, go a little deeper into how I use projects, and even kind of go over a couple of troubleshooting things that I discovered as I've been digging into this. As you can see here, I think the last time I was on here I had a Pixel engine, and then I also had my NitroOS 9 development. I definitely on the Modern Democracy channel I walked through my Pixel engine, which was getting Claude to write a pure HTML, CSS, JavaScript game engine. Then I moved on to NitroOS 9. I think I only posted that video over on my retro channel, but I've been learning some really good best practices on how to use Claude projects. So I kind of wanted to go into that. Let's go into this NitroOS 9 development. A couple of other things actually have changed since the last time I did a video on Claude 2, so I'll cover them as well. One of which is this memory piece. This is something that, if you're more familiar with ChatGPT, it's had a memory component baked into your user interface where would kind of automatically save things that it thought were context that could sort of exist in between conversations. Again, just as a little overview, whenever you start a new conversation with a chat model, most everything that you can speak about in context within that conversation is between what you prompted and what it responds with. This concept of memory allows information sort of pulled out of conversations that it just, like I said, it decides that are important piece of information that it'll sort of persist between conversations. There is also, it's still fairly rudimentary, but there is the ability for conversations to be aware of other conversations, but there's nothing about the way that it works that makes it feel you can really sort of put your finger on exactly how it works and exactly what information it's pulling. So really the bulk of what it is that you're going to be talking about is going to depend on the types of information that you pass into the conversation. Now, with projects, this is sort of a souped up version of what you can do with conversations, where essentially you can see here, these are all the conversations that I've had, and there's even more showing, around this NitroOS 9 development. And in reality, this entire project has been set up by myself to try and, one, see if I could teach Claude to write perfect syntax and implementation of an obscure programming language. Like I said, just given the amount of success that I got with HTML, CSS, and JavaScript, which are the core language of the internet, of the web anyway, I wanted to sort of ramp up the difficulty and bring in not just a language that Basic 09 is a obscure programming language, but it's also it overlaps a lot in syntax with many other languages that are all different variations of Basic, and all models have been trained on far more modern versions like Visual Basic. So by default, it will try to give you suggestions for language variants that aren't this sort of obscure one. To make a long story short, I think I'm at the point now where it's very rare for Claude to write code for me that does not compile and work out of the box. When it does make errors, I did have to make a couple of modifications to my instructions. So each project that I set up, there's a set of custom instructions as well as files that you can link to it. So my custom instructions for this, I've got these actually now stored on my GitHub project that hosts all of this Basic 09 and NitroOS stuff. And I'll link to that in the description below for this video, including the direct link to these instructions. But basically, this is a document that's been evolved as I've it started with the sort of instructions that I gave Gemini when I was trying this with Gemini a few months back, and then I've made some modifications to it. In particular, I've made, actually I think most of this is pretty much the same, and I did cover this in the last video, so I'm gonna kind of skip over it. But I did make a couple of changes. Let me see if I can find them. Oh, the one thing that I did make a big change, that there's a real difference in the way that Claude works compared to the previous models that I worked with, and maybe ChatGPT and Gemini and some of the other big models out there are integrating this to some degree too. But in particular, this comes with the reasoning. So again, that's where when you choose your model here, if you have extended thinking on in Claude's language, but other ones will have something similar that's effectively called reasoning, and that's one of the sort of fundamentals of large language prompting now, is this concept of chain of thought, where you get the model to think through its steps and even question itself and go back and forth to try and make sure that what it's doing makes sense before it gives you a response back. And you'll see that in any sort of prompt, you'll see these, in Claude anyway, you'll see these sections where you can just see a little lighter gray text with the little arrow here, and if I click that, you can see here's the sort of the chain of thought that it's having, including where it goes off and reads files, and it tells you when it finds sections of relevant text from a particular file that it's using, and then it gets type definitions and is looking for these functions, so it's going through source code and documentation for the project. So all of this, and then you even see it might do some sort of pseudocode breakdown. In fact, you can see there's a much bigger conversation it has in here. So all of this gets hidden. Let me show less on that. All of this gets hidden in sort of a roll-up. So by default, you won't see that, but I do like the fact that Claude gives you that sort of drill-in look, that if you like to sort of see what it's doing. But let me go back to the project here in the instructions. One of the things that I found, it was an unexpected development, is that going back in my experience in working with these models and getting them to write code or even to write of any sort of text, give me any sort of product, any sort of document. Generally, I used to have these instructions. Where did I have it? Do I still have something like that? No, but I would have a section that says, before something like this, before submitting or approving any code change, verify that what you say makes sense. And when you don't have that chain of thought process, it really wouldn't work. It would actually spit out the response, and then afterwards it would go back and say, is this right? And I never really got a satisfactory result. So this is one of the first big tips, is in particular formatting what sort of things you want it to avoid as a checklist like this. So where you've got, before submitting or approving any Basic 09 code change, verify, it gives me this checklist. So no reserved words are used as variables, type attributes, arrays, or procedure names. This is one of the ones that even after I did my last video, I was getting it occasionally suggesting like a variable name as one of the reserved words. It's essentially a function in, like POS was a good one. It wanted to use, even though it was lowercase, in Basic 09, lower and uppercase, it doesn't really care. So if you name your variable lowercase p0 POS, there's a basic function that I think you pass a string and maybe a character, and it'll tell you where in that string that character is found, something like that. But anyway, it's a built-in function, and even though it wasn't matching case, it was still trying to suggest these things. So that was one of those checks that I added in here, or I refined anyway, saying no reserved word is used as a variable, type, attribute, array, or procedure. This includes lowercase or mixed case versions of the identifiers. And so there's a whole bunch of good sort of best practices, things that I wanted to check for there, especially things like every end of line comment uses the / exclamation mark and not just an exclamation mark. That was another one that it was making mistakes on when it was writing out code, was that it would just try and do an end of line comment, but it would just put the exclamation mark. So by having this in the checklist section, even if it makes the mistake, it'll then take the code that is generated, and it'll generate the code but not display it to me, and then it'll run through this checklist, and if there's anything it sees wrong, it actually fixes it and then it will present me with the code. So this is if you're finding a model, you want a model to create sort of regular output. I guess like code is a perfect example, but any sort of templated text, having a checklist makes a huge advantage with the reasoning models anyway, or at least the Claude's reasoning model, in that it will do a first draft of what it's planning on telling you, but then go over the checklist and look for that in that document for the specific patterns that you're looking for. Extremely powerful sort of feature that I kind of stumbled upon. I don't know if there's anything else in here other than I did. The other thing that I've just recently added to this was the ability, and I'll get into this maybe on the other video. I might go over it very lightly here, but I have also created two other sort of related projects now. One called the NitroOS Technical Reference Agent, and one called the NitroOS 9 Assembly Source Code Agent. So the biggest limitation to these types of projects is this files section here. And again, I think I went over this briefly before, but when you click files, you can upload, you can have any sort of connectors, and so I've got Google Drive and GitHub here. But so this is the GitHub repository that I have accessible to Claude. But even, and this is, I'll come back to this in a second, but one of the things that I don't want to just give it access to everything in here, because there is a lot of, for instance, this retro MAME developer is a pre-existing GitHub project that I created for not just trying to generate NitroOS 9 code, but sort of as it also has at the root, there's a whole build.sh, which I really ought to split into a separate, I should separate my stocks and bonds GitHub into a separate GitHub project altogether and just link to it, but I was kind of just shorthanding what I was doing. But effectively, there's a whole bunch of stuff in this GitHub project that I don't want the model to know, because if I add everything, I'll exceed the capacity of what it can keep in context, and that's the big limitation right now. I expect in 2-3 years, maybe that will no longer be as well. That context will grow in the same way that it's grown from 100,000 or so words or word segments as a context for a conversation. Now I know Claude, the model that I'm using right now, I think is about 1 million, which is essentially like a very long book, so it can hold quite a lot of information in context. And I'm still only using 11% of this conversation, but in here, one of the things I really like about Claude's project interface on the web anyway, as opposed to the command line utilities that you can do in like Copilot and Visual Studio Code, is that you can really restrict exactly what files. So here I don't even have all the sources in this folder, because in here I've got some test code that I used once and just to run some stuff, but it doesn't need to be part of the context because it's not part of the actual application. Even here there's a couple of tests that I'm currently working on as I'm trying out some NitroOS 9 functionality that I'm not familiar with. I'm running some tests to just sort of evaluate and see, will this work for the approach for what I need. But other than that, I've got mostly here is my stocks and bonds code, and again there's a couple in here that I don't necessarily need it to see, although it should have that one. and it should have that one, and it should have that one. So the nice thing about this is that I can turn on and off documents as I'm working with this. So I've got all my design documents available here, and then I've got a few reference documents, but even this, I've got 2 versions of the Basic 09 Programming Language Reference Manual, but the MicroWare one is more complete, so it's kind of the one I'm defaulting to. This is my conversion of the alpha version of the ease of use manual, but it doesn't go into as much detail on the full spec of the language, and I'm not dealing with the windowing side of things. I'm dealing with a very text-based interface, so for my purposes right now, I've only got access to that. If I added this one in, I'd blow out my capacity too much. So here, I'm going to make an update because I did add some extra sources in there. Every time you update, you'll see that it syncs here. Oh no, I bet you this is going to break, because this is a bug that I've noticed in the Claude interface. So I'm going to have to go and delete this and re-add it again. I'm currently out of tokens, and I'm out of tokens until tomorrow, because I think I've run out of my tokens for the week for the first time. I've been doing a whole lot of work with this. Oh no, it did work. Okay, good. There was a bug earlier though. I didn't, and maybe this has been fixed, but if you ever do see this, if you add something, especially if you get to the point where you run out of tokens and you hit refresh here, I had it so that it would just sit there and spin and spin and spin. It would never stop, which I wasn't sure why. And as long as that's spinning, you can't make prompts with the model. So what I had to do was remove all the files and then go and re-add it with the GitHub and then reselect all the files, and then once I had tokens again, like the ability to prompt the interface again, I delete the old GitHub link, re-add it, add all the files, it'd sync, and then be back working again. But anyway, I just noticed that that seems to be, at least it didn't happen that time. So either it's been fixed or it's an intermittent thing. But there's a good troubleshooting tip for you. If you ever have it so that this sync just keeps spinning, let it go for a while, especially if you've got a whole lot of content in there. It can take a while to actually sync. But if it's sitting there for 5-10 minutes and it hasn't stopped, that's sort of my workaround to how to get it so I can start prompting again. You have to delete it and add it again, and again, ensure that you've got tokens if that is the problem. The other feature that just recently got added was this ability to create graphs and charts within Claude Code. So this one I got it, I don't even know if I specifically see, I've updated the module phase transition document. So this is my, I'll dig into this when I go into presenting the actual code on a different video, but basically this was my, I've had a couple of revisions in my project. I first started with a requirements, actually let me just get a second here. This is Stocks and Bonds. This is an old Avalon Hill game, and it's, the reason why I chose this as a target to implement for this particular project I was working on is because it's a very basic but somewhat realistic simulation of a stocks and bonds game. So it's got 3 pages of rules on one side and then 2 more pages on the back, and one of them is just the you probably can't see this, but it's a securities review. This tells you about the different stocks and how they yield and that sort of stuff. And it does a pretty interesting, it's a, like I said, somewhat realistic simulation of a stock market. So you have this here, I don't know how well this will show up, it doesn't look too bad. So basically you've got a 10-year, which is 10-turn game. You've got all the stocks down here, and then their price varies every year based on a card draw. And so those cards look like this. So this is a bull market, and it's got some flavor text on here. This one says, major coal company announces reduced coal prices to electric power utilities. So Valley Power and Light goes up 5 points on these in value. And then you've got your stocks that you can buy, various different colors and representing the different companies. And there's also a bond, a municipal bond that you can buy, which doesn't change, but it pays a fixed sort of payout every year. And so, this is a multiplayer game. Everybody gets their own stock portfolio here, essentially, and tracks the changes as they add and sell stocks over the years and change in value. And so, like I said, it's a fairly mathematical game, but because it's like I said, it's basically just a set of stocks, and you're tracking each person's portfolio in addition to the current year's value of each of the stocks and bonds. It seemed like and it has a very clear set of rules. It seemed like a good test for taking those rules. So the way I started my project was I took the rules for it and brought them into the game and brought them into Claude, and then worked through a design document that sort of broke down the workflow of how do we implement this as a basic 09 game. So there was a setup phase where we have like a landing menu where you can choose new game or load game or quit. When you choose a new game, it allows you to choose the number of players, what each player's name is, if there's an AI or if they're a human, and also there's a couple of variants as far as stock prices go. But essentially you roll dice and then look up on a table how much each stock goes up and down, essentially. So, like I said, fairly limited set of rules, nothing that requires any sort of graphics. It's just basically you're printing out the current stock price if you're on the sort of the market screen, allowing somebody to go and buy or sell any amount of their own stocks and bonds, and then every year you're making a change to the market, and then kind of rinse and repeat. So I did a design document to start and got about 80% of the project way through, where essentially we built screen or library call one at a time, matched with a test function that would sort of call that function with a bunch of setups for sort of testing the different ways that it could be done. All of that got written by Claude, and then I got to the point where I needed to start integrating things, and that's where I ran into some of the hardware limitations of the platform which I'm developing for, which again is the Tandy Color Computer 3 with Nitro OS 9 ease of use. It needs to have more than the 64K of memory that you would get with a Cocoa 1 or Cocoa 2. Or max out of what a Cocoa 1 or Cocoa 2 can do. But somewhere I'm aiming for at least 512K, 512 to 2 megs ought to be, far more than what you'd need. Anyway, this module phase transition document was sort of after I got through all those screens, I then need to kind of plan out how I'm going to integrate everything. And that's where we had to start working out, the way that Cocoa 3 works is you can only every process can only have access to 64K of memory. And again, it's maintaining backwards compatibility with the Cocoa 1 and Cocoa 2, which had some anywhere between, I'm not sure if the low end was 4 or 16K. I think it was 16, maybe even been as low as 4 in the Cocoa 1. But either way, both Cocoa 1 and Cocoa 2 could be upgraded in memory, but up to a maximum of 64K. The Cocoa 3 has some extra hardware that lets you do essentially paging of memory so that you can swap out. But again, every process inside of Nitro OS 9 is still limited to 64K. And so the question that I had in this conversation was, I've updated the phase transition document in the project's GitHub with a table of all current procedures, their memory size, and the module that they reside in. What's the maximum memory footprint for code between 32 and 40K? Can you evaluate which phases we will run into memory challenges with the current configuration and targeted modules to be loaded per phase? So this is that module phase transition document. So here is where I worked with Claude to sort of assemble, for efficiency's sake, the way I kind of set this up was I created a number of, in Nitro OS 9 language, are called merged modules, where essentially I took a number of procedures that are all sort of in common need, whether they're utility procedures that are called by a whole bunch of the other procedures, or if they're based on a particular phase of the game, they kind of all get bundled into one module. So this is what you can see here. So this is all the different procedures in each of the different module files. And then I ran a utility that got the byte size, and we are measuring everything in bytes because that's how small this code is. And again, we've only got 64K, which is a little more than 64,000 bytes available for the entire process. And that includes not just the code, but also the data. So variables, the variables that actually hold the values and that sort of stuff also take up memory. So you've only got about half of that for code, 32K roughly. So I went and did for every different procedure that I've written, and these are all procedures that Claude wrote for me, and I tested and made bug fixes, and we kind of worked on getting it working. But everything here are the procedures that make up the bulk of the actual engine of the game. And each one of them, some of them are only a few bytes, 87 bytes for some of these, but some of them, like the run year loop, which is the one that is responsible for doing the full year's logic, is 5.5K. And then some of these libraries are needed for different phases. So like I said, in the if I scroll down here, you can see the game gets broken into, so on launch there's very little that you need. Then there's the main menu or new game setup, load game. Each one of those might need different modules. Then we initialize the game, and then we start with the year header. Then we do a revenue phase. Then we do a market phase. So revenue is where you make money. Market phase, so you get dividends and yields. Then there's the market phase where you can go and I think buy, and then trade is the sell. And then margin is where is a variant. You don't have to have a margin, but if you do, you can buy something on margin where essentially you borrowed half the money that you need to buy a stock, but then you have to pay an interest on that margin value until you pay it off. And then there's year end. So year 10, you kind of have to clear off all your margins and figure out who's got the most amount of money. There's also a year save to save the game at the end of every complete year, and then end game and post game. So end game is sort of you decide who wins, and then post game presents you with new game, load, or quit. So each one of these phases is sort of self-contained, and the original theory was I was going to load modules in and out as necessary. Long story short, that ended up not being the right approach, and I'll get more into that when I do my more detailed presentation about how I got Claude to really dig into the other two agents in particular. But going back to my conversation, so that's where it's getting these totals from, is it took it from that table where I had every function, every procedure that's inside of a particular module, what the count was, it added it up and created a table. But this is where it gave me this visualization. This was new as of within the last week and a half, where it actually creates these really nice visuals. And these don't have to be static. You can actually ask for, there was an example that it had. So here's another example of that same graph, same graphing functionality. But this is what, when it introduced it, it gave me a couple of options to sort of kick the tires and see how it worked. And so all it said was, here, prompt me with this. So it said, show me how compound interest works. So here you can actually, you've got active sliders, so you can change your initial deposit, so 13,000, or bring it down to 7,000. You can choose the annual interest rate. You can choose the number of years, and you can choose a monthly addition. So every time you add $50 a month or $100 a month, you can see the numbers go up, the graph changes. So this is new functionality. I haven't really kicked the tires on this at all, but quite powerful. Far more useful than like an image generator, which is kind of what you get with like Claude, with ChatGPT or Gemini. So let me walk through this bit a little more, just to kind of show you how it uses these graphs within the context of a conversation, especially when you're dealing with trying to compare things mathematically. Like I said, I didn't ask for a chart, but it put this in and did help visualize to show show you. So most of these phases we're only getting up around 20K or so. It's only once we get close to 25 that it identified these as yellow as we might worry about these. And these two in particular are really right up against, and this one in particular is phase 910, which it says is, this is where you're doing trade and doing the margin work. This is definitely going to be an issue. So then it also gave more of a breakdown, and then I went and did the splits. So it recommended splitting off SMB trade to pull a couple of the functions out that weren't used in these phases. They were only being used elsewhere. So it said pull those out into a separate module. So I did those, and then it went and I updated. Another workflow here. I don't know if I've mentioned this in the previous video, but one of the sort of downside, I guess it's a little downside, of using GitHub and working with this specific web interface for GitHub is that Claude doesn't automatically know when you've updated your GitHub. So I can make my changes locally, push them up to my repository, but until I come back here and hit refresh, it won't know about those changes. It did tell me what it wanted me to do, so then I said, okay, I've done those updated splits and updated the project's GitHub. Another pro tip, I've found it's very important to tell it to talk about the project's GitHub. If you are using GitHub as a file repository to work with these projects, I've found if I don't include that specific wording, it doesn't always do this. Sometimes it will understand that it needs to go to the GitHub to look at the files, but sometimes it'll come back and say you didn't upload the file that you were talking about. So that's one of those best practices that I've found is tell it when you want it to look at the GitHub project, or the project's GitHub, tell it specifically in your prompt wording that, I've updated the project's GitHub, or look for these files in the project's GitHub, and you get around any sort of the opportunity, any chance that it might misinterpret what you're talking about and think that you're supposed to have uploaded a file. Anyway, so I did the split and uploaded that to the GitHub. So then it went and looked at the change. So we went from 2 libraries, which was SMB margin, SMB trade. We added another one called buy and sell that had those 2 procedures, and then margin screen, which had the screens for the margin stuff, which again weren't needed for all the logic in all the different phases. And then it gave me a nice comparative graph showing me before the split and after the split. So now we went from these 2 being red to now being green or yellow. So like I said, I do really like this graphing thing. This is the only conversation outside of that little demo that I showed that I think we actually worked with graphing, but it is one of those things I'm going to probably look at more later, especially as I get into open data stuff, I think. But just wanted to make a note that if you are trying to work with tables and graphs and data that's tabular in nature, there's some interesting stuff that you can get Claude to do that as either a visual display or even interactive visual display like that other demo that I showed you. The only other thing that I will mention, I think, from the Claude's perspective is the idea around having multiple agents kind of work on a complicated task. The second agent that I created was this NitroOS 9 technical reference. So it's pointing at the same GitHub repository, but it's working primarily off of this document that is a markdown version of a PDF that's available from the NitroOS 9 ease of use documentation page on L. Curtis Boyle's website. And maybe once I finish talking about Claude, I'll do a brief little demo about how I use Gemini to do that translation, because there's another good workflow to kind of talk about there. But essentially, this is a very large document, and so NitroOS 9 is the operating system. Basic 09 is a programming language, one of many programming languages that you can use to write applications for NitroOS 9. So the basic programming language reference manual is a pretty long document. It's at least a couple hundred pages long, I think, as is the technical reference. It's a very, very long document. If I were to add this technical reference to my coding agent, I would definitely increase the capacity, and I wanted to kind of, because I wanted the coding agent to kind of focus on writing basic 09 code, I needed a second agent. So that's what this agent is. I've created custom instructions for it, which I think I got the coding agent to write. But essentially, it's going to identify system calls and other content that's in that technical reference and pull out. So between myself and the coding agent, we'll come up with, here's the project workflow, the specific requirement that we have for a piece of our application that we need to work on. So this did come up when I started running into the memory issues about trying to load modules in and out, and it wasn't really working. I got this agent to talk about alternatives for my approach. What are the different ways that I could sort of deal with the memory limitations but still get all of my code to be able to run in the order that I want to and not have these out of memory errors that I was getting. So it took me several days, probably a better part of a week, to do the conversion from PDF to Markdown, although once I started incorporating Gemini into that process, it really sped it up. And then I started to talk with it. I guess I'd already come up with the idea that I wanted to start forking. So forking is this concept in most operating systems, really. Anything that's a multi-threaded operating system is you can fork a new process and have that process run code. And then you can even have process-to-process communications through different ways, but again, you're kind of in this particular operating system, you're fairly limited in the type of interactions that you can have. But that's what I have been using this technical reference agent for, is I don't know Nitro OS 9 very well. I'm learning quite a bit as I've been doing this project, but I've also been trying to learn Basic 09, and so the other agent has done a great deal in helping me understand writing Basic 09 code. But it's in getting, when I have to get down to the actual operating system level, that's where the limitations of the Basic 09 programming manual kind of really show their head, in that they are more concerned about teaching you how to write code. And what you need to do to really interact with the operating system are what are called system calls, which are essentially assembly language routines that you can call to interact directly with the processor. You actually are setting register values inside of the processor and making a call, which essentially will do a number of assembly language commands, and then return results on those registers that you pull off and then interpret to know what you needed as a result. And all of that is in that technical manual. So again, I created a clear, because there's a pretty clear separation of responsibility here, I created a separate agent that is the technical reference agent. And again, in its instructions, I have instructions about what it's supposed to do and where its authoritative sources are, and in particular, it's that technical reference manual. And then I also want it to do two things in its delivery. Do a syscall research summary. So this tells me, here's all the relevant system calls, how they're, in what sequence they should be called, what sort of error codes, that sort of thing. And then craft a coding agent prompt that I can basically copy and paste these two pieces in my coding agent conversation, and it'll go and write, either develop a plan and implement it, or just write the code directly. So that's been a very valuable workflow, is essentially having different agents with different training, with different tasks, and then sort of going in between them. And like I said, if you craft your instructions well enough, you can get one of them to write the prompt that you then pass to the other agent, and you're mostly hands off. You're just kind of supervising, monitoring, and then putting your hands in when things don't quite work. Extremely valuable. Now, one of the other things that I found was that the technical reference manual may not always be correct, because this is a community community-driven document and a community-driven operating system. This is not a commercial product, hasn't been a commercial product for decades. And so, there's bound to be minor errors here and there. And in fact, one of the calls that I was making, I think I found a typo in the document where it referenced as the value that I was passing at the register was supposed to be in pages. And a page is, I think, 256 bytes of memory. And in reality, I think it was actually, the value is in bytes. And so I wasn't passing the right value in, and I was getting an error. And the technical reference agent wasn't working. So that's where I went and created a third agent, which is the assembly source code agent. And so for this one, I got a fork of NitroOS 9, which is an open GitHub project hosted outside of my GitHub. I created a fork on my repository, so I have access to it. When another note about GitHub with Claude in this particular interface is that you can't link GitHub projects that you don't personally own. So you have to give it permission to access your GitHub repository, and there is a handshake that you'll have to give when you add your GitHub, the ability for it to use GitHub. You have to authorize it through your GitHub profile to say, yeah, I'm allowing Claude to have access to my GitHub repositories. I think you probably also, I don't know if they have to be public or not. That's not something I've tested, but every repository that I demo here is public. That might also be a restriction here, but it may not, given that you are giving it access to your personal or organization repositories. But anyway, so I created a fork of NitroOS 9, and this actually has the assembly, and I've only got a few. This is another one where if I gave it access to everything in here, I'd blow way past the capacity. Even as is, I've given it access to the level 1 and level 2 assembly. So the Cocoa 36309, which is the one that I'm working on, but level 1 in particular, you got the commands. So all the commands in level 1, and the modules, I've only given it access to the kernel. So the real core of NitroOS 9 is the source code that I've given it access to. Now, unlike Basic 09, like I said, is an obscure programming language that has a lot of competing basics that are far more widely known and far more, whose knowledge base has been pushed through all of these models, and they tend to make mistakes on. The nice thing about assembly is that there's far less variation when you get down to assembly. It's a lot easier for it to read, and especially for you're dealing more with the processor, and the Motorola 6809, 6309 processors are pretty well known processors. There's only so many processors out there, and certainly some of these, like these old 8-bits, are very well documented, and I wouldn't be surprised if some of that stuff has been trained. At least from my own personal experience, I found that this agent was actually able to do some pretty good assembly. I haven't used it a lot, but I've actually got it to dig into how different parts of NitroOS 9, like the run B command, what does it do under the covers when it's loading up a module, or how the fork system call actually is coded and what it does under the covers to try and troubleshoot them things, or pack, which is a basic thing. Another really, when you're dealing with programming languages, even down to the assembly level, that are a lot more sort of general purpose or widely known or more modern even. This isn't modern, but like I said, assembly is kind of assembly. That hasn't evolved quite nearly as much as, at least at the rudimentary level, than say something like BASIC has. And is the environment isn't quite, you're dealing at the processor and the hardware level, so it's a lot less variation between platforms. Anyway, so between these three agents, I found I got a really interesting workflow here going, and it's really helped me learn about NitroOS 9, Basic 09, and the assembly level side of the 6809 processor, and also helped me learn a lot about how to design different agents with different tasks at the technical level. This has worked extremely well. It's even helped me identify a alternative approach and started me building test code that helps verify how I'm going to be passing information between my different processes. But again, I'm not going to get into that for this video because this is more of a how I'm using Claude to do some pretty technical development. Last thing before I go on this video, I wanted to show you how I used this is a really common pattern for when you're trying to convert documents from one format to another. This is the document that I was working off of. So you can see here, this is a PDF. It does have hyperlinks and whatnot, but it's, you know, a decently formatted document. It's also got like page headers and page footers with a page count. And while PDFs are useful for humans, they're not. Well, for one, Claude doesn't really handle PDFs very well. Google can, but it's not really a good format for computer processing, for models. So what I needed to do was to convert this to a text-based file structure, and I used Markdown just because I find it's simple. I don't have to do anything too complicated. It doesn't have to have all the fancy, you could use something more like ASCII doc or some other more, in fact I think that's what these PDFs are written in, is ASCII doc, but I don't have access to those. In either case, I wanted to have this in a simple text format, and Markdown, if you haven't used it before. So it's just got some basic some really simple things like hashes create titles, stars create bold, or you can do italics, you can do underline, hyphens at the start of a sentence will do sort of bulleted lists, or numbers will do numbered lists. If you do this where you've got headers, and now usually you would have column names up here, but you can do a sort of an empty column header table to just give columnized views, doing something like this where it'll give you some nice horizontal formatting and everything aligned in columns. So you can do some really basic, and then you can also do code snippets. So here whereas this is formatted text, this is unformatted, so it's all monospace. So this is how you can do like a rudimentary diagram. My workflow, the way I get this to work is I start with an input document. So I used a free online PDF to Markdown utility. If you just search PDF to Markdown, you'll probably find it was one of the first ones off the list. But effectively, it spits out something like this. Now, this is not well formatted. It's also got things like, so this is that page header that's on every page in a chapter, and you might even see page numbers. I think sometimes it takes it out, but sometimes it doesn't. You get something that's got the basic content of the text, but maybe it doesn't always format things. So here we've got this sort of X pointer is pointing at this. There is some graphing, and it's using also sort of code blocks to kind of do sort of monospace text in rows and columns. But it's not really all that readable. But really, one of the things that models are extremely powerful at doing, which is repeated tasks, provided you have a template that shows here's an example of what you're going to see, and here's an example of what that example looks like converted into the format I want it to look like. So input, like I said, it's kind of ugly. It doesn't have, like, this is something where this is just lines of text. It's not being put into any sort of table. But you can see if I switch to the input, from the input to the output, the same text content is here, but instead of having just this as a single line, it's been put inside of a table, and we've put titles at the top for each of these. So these are the system calls. So the big part of this document, this first part was mostly text, and this is something that I could just do. I mostly did this by hand, although some of the stuff I kind of set up. But once we get down, like I said, most of this document, so you can see from page 1 to page 104. So the first 100 pages is very much more text dense and paragraphs, and was fairly easy to transform just using macros and text editors and stuff. But getting to here, so from 108 down to 265, so 160 some odd pages, we had this exact, once we get into here, this is sort of the standard format. So that this is the type of page that we were getting. When I did the PDF to Markdown, it would take this where you had this is sort of the, well, except for that title, you'd have your name of your system call, a brief sentence that described what the system call did. The OS9F $alarm is how you can call it from the command line, I think. This is the, I can't remember what the term is, and then this is the symbolic code. So if you're calling this using the syscall inside of Basic 09, this is how you identify the system call, is this value here. And then you have entry conditions, which are, so these are the registers. If you aren't familiar with how a computer processor works, every processor has essentially a pipeline of instructions that get sent through it, and it has a number of what are called registers, and this comes from the old adding machine mechanical calculator days, which are essentially little memory spots of 8 to 16 bits in the case of this processor, and they're all named A, B, C, D, X, Y, U, although U is A and B. Actually, I'm not sure if D is this thing. CC is like the carry set. B is used as an error reporter sometimes. But anyway, so what this document tells you is which registers you need to set when you're calling this, what registers are going to be returning meaningful information, and then what registers to check if there was an error. And then it also gives you some additional information. And each one of these looks like some variation of that, right? So, sometimes there's indented stuff, and sometimes there's a little basic diagram, but even some of these diagrams were consistent. So as I evolved my process kind of working through this, I would come up with some of these in my template too. So anyway, what I'm trying to do is start with that input, which is, so this is that big unformatted block of Markdown that I got from that free PDF to Markdown converter. And then I formatted it so I got it the way that I wanted, including, so here you can see one of those little diagrams. So that looks like this in the converted stuff. So it's not anywhere close to representative, but because it can sort of, this rough pattern would look the same if it ran into it again, it was able to actually kind of create even these nice little formatted text diagrams. So I did it for a few of them. I did it for chain, I did it for clear, I did it for, that was it for this one. As I was working through, I would modify these as I got to different sections, because the system calls were different from the user calls, which were different from the IO calls. There were minor variations, so I was massaging these, but I would provide the input, the output, and then I provided the converted document, which was a big block of pages from that document. And then it went and again, I used the thinking model, so the reasoning model in Gemini, and it spit out the formatted text, which then I would come down here, even creating those little block texts. And then at the bottom, like I said, it did a whole lot. I would just go copy this, strip out the parts, like there's a couple things here, like additional instructions and things I'd strip out, or maybe a little preamble at the top. Paste that in replacement of the text that I used to create my convert document, and then walk through it just looking for errors. And most of the time it was great. The only thing that again, because context windows you've only got 1 million tokens in Gemini to be able to hold in context, and when you're dealing with, even with this process, when I get into the dozens of pages, I did find that as I started working down the page, some of this text would be less word for word and more, it would start to paraphrase or reorganize things or cut things out. Mostly of that happened in the additional information. This stuff where it was all pretty much symbolic and then a brief little bit, maybe it might slightly change this, but it was a lot faster for me to just copy out the stuff I want to convert it, pass it into this process, and then take the stuff out and then just sort of proofread it and copy and paste in the text from the original source when what it spit out wasn't the exact text. That sped up my whole process multiple fold. It was many times faster than doing it by hand. So, and you can do this, like I said, if you've got, this is another really great tip for using these, and this works for every large language model. But Gemini in particular works really well with this because it has such a large window. Claude would probably do this very well as well. If you're ever having to do large document processing and you've got lots of repeated formatted blocks and you want to go from one format, whether it's ugly or not, to another format, as long as you create a template that shows sort of representative of the most common cases of what it looks like and what I want to look like, you can rapidly speed up your ability to do these transformations and process large documents much faster than if you're having to do it only by hand. That is my last tip for today. Thanks for watching. I hope I'll be cutting this in together. This will probably end up being about an hour-long video, at least to be my guess at this point, but I appreciate your patience. I will put chapter markers in here so you can sort of skip ahead, especially for, I'll make sure to highlight the specific, the real tips parts as specific sections, but I will try and chapter marker everything to make it easier to navigate. I hope you found some of this or all of this useful. I will be back on my retro channel really digging into how I use Claude to build this project that I'm working on. It will probably be a couple of videos on its own right, just simply because there's a lot to dig into. But between the HTML project and this Basic 09 project, there is no need to write code of any sort anymore. As long as you have good methodologies, you have prepped the priming information, so the instructions and the source material that's in a good format for the model to look at, you can get a model to write almost anything. So I hope if you take nothing away from this video other than that, you let that sink in. We're at a cusp of a massive change in the way that we work with a computer, thanks to these models. Oh, one more thing. I want to make, I'm only going to reference it. I won't go into any real detail on it. I did have, let me bring up my Visual Studio Code. Okay, one more thing. I did try using the Copilot in Visual Studio Code, using ChatGPT, I believe is what it's using. I did try it for a couple of conversations, and I was not particularly impressed. Now, I expect there's probably some tuning that I can do, but by default, just to kind of talk about why I really like the Claude web-based interface for projects, is by default, I have to explicitly add what files I want it to be able to look at and to work with. By default, the way that this command line interface in Visual Studio Code works for Copilot is it has access to everything in your project. So I ran a few different conversations with Copilot, and two of the big issues were, one, it tried to write Basic 09 code without really understanding how to do it. I did add a Copilot instructions document, which is essentially a verbatim copy of my Claude project instructions. It didn't seem to follow it very well. And the other the more alarming thing that I found was, even when I was asking it to do a little bit of research or ask for a very simple question, I found it start like modifying files throughout the entire repository and doing all sorts of stuff. It was just way too much, way more power. Now, like I said, there's probably a steep learning curve to getting it to do similar things to the way that I like Claude's Project Online interface working, but again, this is a matter of a user experience difference. So the command line interface with Visual Studio Code, well, I expect it's extremely powerful. And maybe if you're dealing with a project that's a lot, small and simple, or even just really well documented, and you've got the right exact instructions set up and restrictions set in, you might be able to get a similar sort of workflow. But do not use it with its default settings, because it will do all sorts of stuff. I mean, you can always say, no, don't change that file, but like almost every time I asked it to do something, it did 2 or 3 things I didn't ask it to do, or did things in the completely wrong way. So it's just, me personally, I much prefer a web-based interface where at least when I'm working with something that's on a publicly accessible interface like GitHub, I find using the Claude's project management far better than trying to use something like Visual Studio's command line interface Copilot. There are other command line interfaces. There's even Claude Code, which you can work with on your local environment, that I haven't played around with. But like I said, for my own internal purposes of how I'm using these tools, I find, it's certainly for now, the Claude web-based interface is far more user-friendly, far easier to use, and it's far clearer. It's much clearer exactly what the model has access to, what it's supposed to. It's much easier to make sure that the instructions you're telling it are going to be followed. And there's a little bit of ugliness in that. Like I said, when I push something up to my GitHub, I then have to tell it to refresh or to detect those changes. But maybe that's something they'll fix. They'll have something that will check every now and then, looking for updates to the public interface, and do that automatically. For now, it's a minor annoyance, but I find I enjoy that Claude project interface far better for right now. The only downside, as far as the free side, is one, you've got limited number of prompts, and you have I think you're limited to maybe 10 or 12 projects. But for my purposes right now, it's more than enough for what I need. So anyway, if I don't use my other wrap-up, or if I have this after that wrap-up, I will wrap it up now and say thank you very much, and I will talk to you next time. Bye-bye.